Hi students, today we will discuss a small concept, that is radical axis, small but a very important concept. We will discuss about radical axis. What is radical axis? The locus of a point which moves such that the power of that point with respect to non-concentric circles are equal is called a radical axis. The power of a point. What is the power of a point? If you don't know, in description I will give link. Please once go through that video. If you take this definition, the locus of a point which moves such that the power of a point with respect to two non-concentric circles. If you take two non-concentric circles, C1, C2, this is S is equal to 0, this is S dash equal to 0. The locus of a point is all points. If you take any one of these points, the power of a point is nothing but, if you take S is equal to 0, S11 is nothing but power of that point. If you take S dash equal to 0, S dash double 1 is nothing but power of point with respect to the second circle. Then these two lengths are equal. S11 is equal to S dash 11 is called a radical axis. These two equal means that is all points. If you join them, this is the locus of all these type of points. If you take this point, this is equal. The power of all that points is nothing but, if you take power of all these points, just if you write square root, this will become length of the tangent, right? Length of the tangents are equal. That means you can see second definition, locus of a point that moves in such a way that the tangent lines drawn from it to the two circles are of the same length. We got same length, no? Is called radical axis. So this is radical axis. Then that means you can take any point here, this length of the tangent with respect to first circle, this length, these two lengths are equal. Power of a point or length of the tangents from a, these all points are equal. Then this locus of this point is called a radical axis. Okay, I hope you understand. And then how to find out this radical axis, let us see now. Okay, now how to find out this radical axis, let us see. To find out radical axis, let us take a point P x1 y1, the locus of a point x1 y1. P x1 y1 is a locus of a point and then according to definition what we got, this is S is equal to 0, this is S dash is equal to 0, then power of a point is equal to, with respect to first circle, equal to power of a point with respect to the second circle. Then S double 1 is equal to S dash double 1, or some lectures will write S1. Okay, that notation. S11 is equal to S dash 11. Then S11 is nothing but, here S is x square plus y square plus 2gx plus 2fy plus c is equal to 0, where s dash is x square plus y square plus 2g dash x plus 2f dash y plus c is equal to 0. Then S11 is x1 square plus y1 square. Just instead of x and y, you have to substitute x1, y1. x1 square plus y1 square plus 2gx1 plus 2fy1 plus c is equal to s dash 11 is x1 square here as c dash, x1 square plus y1 square plus 2g dash x plus 2f dash y plus c dash. Clearly both sides x1 square plus y1 square will cancel. So the three terms, if you transpose this side, we will get 2gx1 minus 2g dash x1, this is x1 y1 sorry, plus 2fy1 minus 2f dash y1 plus c minus c dash is equal to 0. Then in these two values, if you make x1 common, 2x1 common, no? 2 into g minus g dash into x1 plus 2 into f minus f dash into y1 plus c minus c dash is equal to 0. So clearly this is in terms of x1 y1 linear equation we got. So the locus of x1 y1 is, whenever if you want to find out a locus, at last x, so instead of x1 y1 you have to write x comma y. Then the locus of px1 y1 is 2 into g minus g dash x plus 2 into f minus f dash into y plus c minus c dash equal to 0. So this is equation of the straight line, right? X, y and constant. So radical axis is nothing but equation of the straight line. This is the, so clearly this to find out equation of the radical axis directly, s minus s dash equal to 0 you can use. S minus s dash, if you subtract these two directly you will get this, right? So equation of a radical axis is s minus s dash is equal to 0. Now let us discuss properties of radical axis. So here some properties are there, let us see what are the properties. This is C1, C2, this is S is equal to 0, this is S dash is equal to 0, where S is, just now we have written x square plus y square plus 2gx plus 2fy plus c is equal to 0. Then C1 is minus g comma minus f, right? Minus g comma minus f. S dash is x square plus y square plus 2g dash x plus 2f dash y plus c dash is equal to 0. Then the center of the second circle is minus g dash comma minus f dash. Then property number 1 is a radical axis always perpendicular to the C1 C2. The line segment joined by two centers. Let us see how this is. So just now we found a radical axis equation, 2 into g minus g dash into x plus 2 into f minus f dash into y plus c minus c dash is equal to 0. This is radical axis, equation of the radical axis. What is the slope of radical axis? Slope of radical axis is equal to, this is look like ax plus by plus c is equal to 0. Then slope of a straight line is minus x coefficient by y coefficient, then minus 2 into g minus g dash by 2 into f minus f dash. Then 2 gets cancelled, minus if you multiply with minus or minus of g minus g dash by f minus f dash, right? So this is slope of the radial axis. Clearly, slope of C1 C2 can find out. Slope of the C1 C2 is equal to, we know that when we know the 2 points, slope is equal to y2 minus y1 by x2 minus x1, right? Difference of the y coordinates by difference of the x coordinates. Then minus f dash y2 minus y1 minus of minus no plus f by minus g dash minus of minus g means plus g, that is nothing but f minus f dash by g minus g dash. Then if you multiply these two, we got the slope of the radial axis and slope of the C1 C2. So if you multiply slope of the radial axis into slope of the C1 C2, clearly you can observe this is minus of g minus g dash by f minus f dash into this is f minus f dash by g minus g dash. So these two gets cancelled, these two gets cancelled. Product of the slopes we got minus 1. So the product of two lines is equal to minus 1, that two lines are perpendicular to each other. So property number 1 is a radial axis always perpendicular to the C1 C2, line joined by C1 and C2, right? This is first property. Next, property number 2, a radial axis is always nearer to the center of the smaller circle. Let us find out how it is nearer to the smaller circle. See here, we will take a point on the radial axis which is P. According to definition, from P to, if you draw a tangent to the both the circles, they are equal, right? According to definition, these two lengths are equal. So let us take this length is any constant k. Let us take constant value k. Then this is the point of contact. If you join this, this is radius. Radius is always perpendicular to the tangent. In the same way, this is point of contact. If you join this, this is also radius is always perpendicular to the tangent. So from P to this S is equal to 0, from P to S dash is equal to 0, we have taken two tangents. These lengths are equal by definition of the radial axis, right? Now, a radial axis always nearer to the center of the smaller circles. How it is we are doing? Proving. Let us take this point of contact A, this is point of contact B. Clearly, triangle PAC1 is a right angle triangle, right? Triangle PAC1 is right angle triangle. Right triangle. In the right triangle, hypotenuse square is equal to, that means C1P whole square is equal to AP square plus C1A whole square. Then C1P square is equal to AP. AP is nothing but K. We have taken as K. K square plus C1A square. C1A square is nothing but this is R1, radius of the first circle. So R1 square. And if you take triangle, second triangle, if you take triangle PBC2, this is also right triangle. Angle PBC2 is equal to 90 degrees. Then this is right angle triangle. By Pythagoras theorem, C2P whole square is equal to hypotenuse square equal to side square plus side square C2B whole square, right? Then C2P whole square is equal to PB square. PB is nothing but K, we have taken K square plus C2B is nothing but this is the radius of the second circle R2. So C2P square is equal to K square plus R2 square. Then this length and this length we should compare. To compare this, clearly R1 is greater than R2, right? R1 is greater than R2. This is small circle, this is greater circle. R1 is greater than R2. Then R1 square is greater than R2 square, right? There is no change in inequality. R1 square, both the sides of the inequality, if you add some constant here, see, you can observe, here K square is there, here K square is there. If you add K square, R2 square plus K square, then R1 square plus K square is nothing but C1P square, R2 square plus K square is nothing but C2P square. That means C1P square is greater than C2P square. That means if you take square root on both sides, C1P is greater than C2P. So what is the meaning of this? C1P is greater than C2P. That means P point to C2 distance, P point to C1 distance is more than C2P. That means radical axis always nearer to the center of the smaller circle. This is the property number 2. Okay. Property number 3. A radical axis is always nearer to the circumference of the big circle. Means if you take this point as M, this point as N, this point is M, this is a P point, okay, this point P, this is M point, this is N point. That means PM is less than Pn. How it is? Let us check it once. See, as we got C1P is equal to square root of R1 square plus K square. C2P is equal to square root of R2 square plus K square, right? Now this PM is equal to, and that means this length is equal to PC1 minus CM, we can write na, C1M. PC1 minus C1M. PM length is equal to PC1 minus MC1 or C1M, we can write. C1M is nothing but R1. That means PC1, what we got, PC1 or C1P is equal to root of R1 square plus K square minus C1M R1. In the same way, PN length, PN is equal to PN, you can write as PC2, that means C2P minus C2N, you can write. So C2P we got as square root of R2 square plus K square minus C2N is nothing but R2, right? This is nothing but R2. Then we have to compare these two. So clearly these two we can compare, but this is R1, this is R2. Here positive sign is there, you can compare very easily, but here negative sign is there. Whenever negative sign is there, we have to make it positive, then we can compare easily. So we will do rationalization. Then we will get here R1 square plus K square plus R1 square by square root of r1 square plus k square minus r1. Just root of r1 plus k square, r1 square plus k square minus r1. Numerator and denominator we have to take plus and multiply. Then in numerator you will get a plus b into a minus b, that means a square minus b square formula. If you apply, you will get this. In denominator, this value plus value you will get. Then r1 square, here minus you will get, minus r1 square plus r1 square will get cancelled. We got here k square by root of r1 square plus k square plus r1. So if you don't understand, if you didn't understand, once you see, look at here, how we got is root of r1 square plus k square minus r1 divided by, we should multiply with conjugate of this, that means root of r1 square plus k square plus r1 by root of r1 square plus k square plus r1. Numerator and denominator we have to multiply with this, that is called rationalization. I hope you understand. So now we got this. In the same way, this one, if you rationalize this, directly you will get k square by root of r2 square plus k square plus r2 you will get. This is Pn, this is Pm. Now you can compare easily. How to compare? Let us see. We are comparing now Pm and Pn. So to compare this, already we got is r1 square plus k square, r2 square plus k square. As we know, r1 is greater than r2, then obviously this is greater than this one, right? Next, root of r1 square plus k square, if you add r1 this side, greater than root of r2 square plus k square plus r2. Just these two, this is equation number 1, this is equation number 2. If you add these two, we got this. If you reciprocal these two, what will happen? 1 by root of r1 square plus k square plus r1 is less than. If you make it reciprocal, what will happen is greater than becomes less than 1 by r2 square plus k square plus r2 square root of. So both sides a non-negative number k square, if you multiply, you will get directly k square like this. That means this is nothing but Pm, right? We got Pm. This is nothing but Pn. That means Pm is less than Pn. Pm is less than Pn we got. This is the smallest distance than this. What is the meaning of that? So, the circumference of a big circle is nearer to the radical axis, or clearly you can say a radical axis is always nearer to the circumference of the big circle. So, this is the property number 3. Based on these 3 properties, we will discuss the radical axis in relative positions of 2 circles. How we will get? Let us see. If 2 circles are equal circles, if you take 2 circles are equal circles, if you take, exactly perpendicular bisector is the radical axis. That means this is the midpoint of C1, C2. Here R1 and R2, R1 equal to R2, R1 equal to R2. In this case, that means that these two circles are same circle, equal circles. Then radical axis is perpendicular bisector of the C1, C2. That means this is the midpoint and this is perpendicular. According to properties, three properties. Property number 1, radical axis always perpendicular to the line segment joined by C1, C2. That is first. Second one, a radical axis, second one, not in this case. Generally, a radical axis is nearer to the center of the smaller circle, and radical axis is nearer to the circumference of the big circle. Please remember these three properties. Based on these three properties, we can decide in the relative positions of two circles where the radical axis will become. So, if two circles are equal circle, radical axis is perpendicular bisector of C1, C2. Next, case number 2, if two circles are neither touch nor intersect, this kind of circles, in these circles, according to three properties, a radical axis is nearer to the center of the smaller circle, radical axis perpendicular to the C1, C2, radical axis nearer to the circumference of the bigger circle. So, how to find out this one? S minus S dash equal to 0 in this case. In any case, S minus S dash equal to 0. If two circles are intersecting circles externally, that means then radical axis will be clearly these 2 points. If you take A and B, length of the tangent from A to this circle, from A to this circle is 0, right? In the same way, the length of the tangent from the point B to this circle and this circle equal to 0. Then a radical axis will be this one. This is nothing but common chord. In this case, common chord of these two circles is radical axis now. So, in this case, radical axis is common chord. So, same S minus S dash equal to 0. You can find out. You will get you make sure that while finding radical axis equation, these two equations S equal to 0, S dash equal to 0, x square, y square coefficient should be same. Then only you can, if you subtract them, you will get a straight line equation. Otherwise, it will be wrong. You will get. So, please remember this point. Next, first case, if two circles are equal circle means perpendicular bisector is the radical axis. If two circles are neither intersect nor touches, so in this circles perpendicular only outside of these two circles we will get this one. Next, if two circles are intersecting circles externally, then common chord is nothing but radical axis of this. Next, if two circles are touch each other externally, then if you take this point from this point to this line, this circle tangent, length of the tangent from this point to this circle length of the tangent is equal, that means equal to 0, then you will get like this. Common tangent, here radical axis is in this case common tangent. Radical axis is nothing but common tangent in this case. Next, if circles are touch each other externally, if circles are touch each other internally, then you will get like this. Then this is clearly it is nearer to the smaller center of the smaller circle. Okay, these three properties you should remember always. So if touches two circles are touches internally or externally, the radical axis is, here also radical axis is common chord. Radical axis is common chord. Next, in the next case, sorry, these are all completed. Yes, that means one circle completely lies another circle, then like this. If these two circles touch each other internally, means radical axis is the common tangent, right? Common tangent will be here. That now if you take these two, this is C1, this is C2. A radical axis will write here, will draw here. No, because according to properties, what is the property? Property number 1, radical axis is always perpendicular to the C1, C2 line segment. Second one, a radical axis is nearer to the center of the smaller circle. So if you take here, it is nearer to the bigger circle, right? So we can't take here, remember. So you can take here. It is radical axis nearer to the smaller circle, a radical axis nearer to the circumference of the big circle. So it is satisfied now. First property is it is perpendicular to the C1, C2. Second one is C2, that means the radius, the center of the smaller circle is nearer to the radical axis. If you take this side, then only these three property will satisfied. If you take here, it is that properties will not satisfied. The importance of the properties will know here only, in this case only. You can't take this side. Okay, this side only you can take. See here, radical axis nearer to the center of the smaller circle. A radical axis is nearer to the radical axis is nearer to the center of the smaller circle. A radical axis is nearer to the circumference of the big circle. It is perpendicular to C1, C2. In this case, these three properties very useful, because this side only you have to take radical axis. This side you can't take. If you take this side, what will happen? C1 is nearer to this one, big circle center. So it is impossible. So this side. So as move this side, if you take this side, circle if you take here, so it will move like this side, right side. The circle moves, the smaller circle moves left side, the radical axis moves right side. Okay. So if it is moves this side, what will happen? Then if you take this side, now radical axis will be this one. If in this case, the three properties very important in this case. You can understand now. I hope you understand. Next, last case is if two circles are concentric circles, a radical axis will not exist. Why? Because suppose if you take x square plus y square is equal to 4, x square plus y square is equal to 9. These two are concentric circles, right? What is the formula to find out radical axis? S minus S dash equal to 0. If you subtract these two, 0 is equal to 4 minus 9 or 9 minus 4, you will get 5 or minus 5. So 0 is not equal to 5. 0 equal to 5 we got. Okay. 0 equal to 5, is it correct? No. So that's why in the case of concentric circles, a radical axis does not exist. Please remember, these are in different relative positions of two circles. A radical axis where we will get, we have seen. I hope you understand.